Good morning. I'm Hussain, former professor, Department of Chemistry, University of Dhaka. This is the lecture series of AS and A-level chemistry, and this is the 31st lecture, and it is specifically on organic chemistry 6. Well, in the last lecture, we were talking about polymers of organic chemistry, and it's a big subject, but we take that polymer only for AS level, that is basic polymer. Now we are going to talk about a homologous series of alcohols. So like other homologous series, alcohol does have a general formula CnH2n plus 1 OH. Okay, the name, we know that alkane is one of the homologous series. If we take alkane and add only NOL, it means then we are talking about alcohol. For example, ethane, we are having this formula, structural formula, and that's what is called methanol, you see, ANOL, methanol. Classifying alcohols also a very important part, how we classify alcohols. We will see that there are different types of alcohol. For example, primary alcohol, secondary alcohol, tertiary alcohol. How do we classify primary alcohol? You see, this is what it is. This is a hydrocarbon, and then we are having a OH here in the end of the hydrocarbon chain. And that's what we call primary alcohol. Okay, now we see that there is a chain, a hydrocarbon chain, but that alcohol is hydroxyl group is attached to a CH group. Not here it is, you say that it is attached to the CH2 group, but here in this case it is attached to the CH group, this hydroxyl group. And this type of alcohol we call secondary alcohol. And then we see another, we have that the carbon atom attached to OH group has got 3 alkyl groups. And this is called tertiary alcohol. We can call it, name it, not primary alcohol also, but we can say propan 1-ol, and then propan 2-ol. What it is? 1 is the number of the carbon atom in the hydrocarbon, and this is the 1 carbon atom, and therefore we call it propan 1-ol. And here it is 2 carbon atom, and they call it propan 2-ol. And then here you see 2-methyl propan 2-ol. So that is primary, secondary, tertiary alcohol. Okay. Now the numbering to show the position of H group is starts at the end of the molecule, which I already said. So primary carbon, that's what I explained in this figure. We go to next slide, and then we see that it is not only one hydroxyl group we get in hydrocarbon, and so we do have also 2 hydroxyl group, 3 hydroxyl group, and how then we name those. So we know ethane can form ethane 1,2-diol. What it is? This is ethane. So we have 1 OH group. So ethane, we can, where it is? This is the butan 1-ol, a primary alcohol. If we go here, you see that it's OH is attached to CH group here, and it is this 2-butan, so butan 2-ol, and it's a secondary alcohol because it is attached with CH group. And then we have this is attached with this 2-methyl propan 1, or it's a primary alcohol group. It is attached with this one. This hydrocarbon, it is attached with the CH2 group. So therefore, it is a primary alcohol. And similarly, we talked about tertiary alcohol. This is, you see, four isomeric forms of alcohol. It's C4H9OH. Okay. The final E in the ethene, you see, E in the ethene is not removed when naming the alcohol having more than one OH group. So you see, in this case, we have an example here that we have ethene and then CH2 group and OH group is there, and in this CH2 group an OH2 group is there. So we call it ethane 1,2-diol. Okay, here again, you see, if we go, this is one CH2 group, this is another CH2 group, and this is a CH group, and therefore it is propane 1,2,3-triol. 3 hydroxyl group, and that's why we call it triol. So there are different ways of naming alcohol, but then with the main name is called primary alcohol, secondary alcohol, tertiary alcohol. We will come to it again when we are taking the reactions of this alcohol. Okay, properties of alcohol. Yeah, we said the methane, ethane, these are the alkane, and their simplest alcohols are methanol, ethanol. We see this methanol and ethanol are liquid under the same condition as methane and ethane are gas at room temperature. So there is a subtle difference between methane, ethane and methanol and ethanol. And why this is? This is because there is hydrogen bonding in alcohol. With the OH group, there is hydrogen bonding. And for hydrogen bonding, it is more stable than its corresponding alkane. We talked about hydrogen bonding when we were discussing bonding, chemical bonding, details we talked about it. We have to remember that is that hydrogen bonding, which is responsible for the physical properties of alcohols. Okay, chemical properties of alcohol. We see that in alcohol we have got CO bond and also OH bond, is it not? So if we have this bond and this bond, there must be electronegativity difference in these two, and therefore these bonds are polar bond molecules. These bonds are molecules polar. So we can burn alcohol. It's a chemical reaction. Burn alcohol with plenty of oxygen, and then what do we get? We get carbon dioxide and water. I can give a tip here. You see, when you do so, write an equation of combustion with 1 mole of alcohol. So we have 1 mole of alcohol, methanol. And then use the fractional moles of oxygen. And this is 3/2 oxygen moles. When we react, we get carbon dioxide and water moles. And it is a balanced equation. Balancing equation, we do have to remember the oxygen of alcohol also to balance the equation. Well, we could have substitution reaction. What do you mean by substitution reaction? If we remove alcoholic group, that is OH group, by say another atom or elements or another group. So in this case, we are talking about halogen atoms. If we remove this alcoholic group with halogen atoms, what happens then? This is the type of reaction, what we call substitution reaction. We can use several reagents for substitution reactions. For example, phosphorus halides, for example, hydrogen halides, etc. Chloroalkanes. So how do we prepare chloroalkanes? We take alcohol and then phosphorus pentachloride solids, and that gives us chloroalkanes. And phosphorus oxychloride and hydrogen. chloride gas. Tertiary chloroalkanes can also be prepared by tertiary alcohols. We were talking about your primary alcohol, secondary alcohol, and tertiary alcohol. Here we are again coming to that we can prepare tertiary chloroalkanes from tertiary alcohols with concentrated hydrochloric acid. But concentrated hydrochloric acid, if we want to have chloroalkanes from primary alcohols, you will see that this is a very slow and not suitable reaction for synthesis. Bromoalkanes, we do have two different types of preparation techniques of bromoalkanes. What you can take, we can take an alcohol and heat with hydrogen bromide and get bromoalkanes. But in case of hydrogen bromide is one of the, but we can also do it sulfuric acid. In presence of sulfuric acid, you usually can have bromoalkanes. In that case, we use phosphorus 5 bromide, that is phosphorus 5 bromide or phosphorus 3 bromide. And in phosphorus 3 bromide, where you can see that we can have alcohol and then phosphorus 3 bromide solids, and then we get bromoalkanes and phosphoric acid. Similarly, we can go for iodoalkanes, and in this case, we use phosphorus iodide. And we don't use phosphorus, we use in situ rest phosphorus and iodine and form phosphorus iodide, and thereby we get iodoalkanes. I come to the next slide, and there we can see an experimental setup for synthesis of 1-bromobutane. There are 5 steps, and this is what is shown in equipment and experiment setup. We take a refluxing ground joining apparatus, and there we use butane 1-ol, that is a primary alcohol, and with sodium bromide and 50% sulfuric acid. And if we reflux it, and after reflux, what we do, completing the reflux, we then take out impure product in it from this mixture. From this mixture, after heating, when it is refluxed, we take this and heat this and distill the impure product, and therefore we can purify the product of what we call 1-bromobutane. And how do we purify? You purify this 1-bromobutane prepared with washing and in hydrochloric acid and remove unreacted butane 1-ol. And then after them, we wash this with sodium bicarbonate and remove the acids. And then we have this organic, purified organic bromobutane 1, and we dry this then. And when we dry it, what we use sodium sulfate as a drying agent and in a refluxing flask. And then we take this dry bromobutane 1 and distill it at a certain temperature. And that temperature is, we get the fractionation of temperature between 100 degrees Celsius to 103 degrees Celsius, and we get pure bromobutane by this. This is an experimental setup I show, and sometime you get this sort of question in your exam, A-level exam, how to prepare things like this. Well, now we are going on discussing another chemical properties of alcohol. First question is, does organic alcohols more acidic than water? What do we think about this? We know that if we want to dissociate an alcohol, what happened then? We get ethoxide ion and hydrogen ion. So it is an ethoxide ion and hydrogen ion. The degree of dissociation depends on how strong acid we get. So this dissociation, we see that the equilibrium point is over that. Therefore, we get little dissociation, undissociated, more undissociated ethanol. And even if compared to this dissociation of water molecules, we see that this dissociation is less than that of water molecules, and thereby the organic alcohols are less acidic than that of water. We have to remember that. Therefore, ethanol is weaker acid than water. We said it. Okay, then this is why it is. This is because electron donating alkyl group bonded to negatively charged oxygen atom and the etoxide. Therefore, this is why we get this methanol. They're acidic, but less acidic than even water. Reaction to make alcohols. What are the conditions we can make alcohols? What do we do? We know that alcohols do occur in nature. Where, for example, we rotten fruit and that undergoes fermentation and get alcohol. But there are plenty of other ways for chemists to produce alcohols. Next slide summarizes this reactions. What we do, we take ethane and with steam and phosphoric acid as a catalyst, we get ethanol. This is one of the very known way to make ethanol. Well, we can also oxidation of alkenes with dilute acidified potassium permanganate to form a diol. That's what is. This is ethene, you see, and alkenes, and then we have water. And this sign says that it is going in oxidation state here. And therefore, with oxidation of ethene, we get ethane 1,2-diol. But remember that we said that we could have two hydroxyl group in a organic alcohol, three hydroxyl group in organic alcohol. So here, this is how we can form ethene 1,2-diol. This is nucleophilic substitution. We can hydrolyze bromoethane, and then hydrolyze by sodium, aqueous sodium hydroxide, and then we get ethanol, you see. So, and sodium bromide. We can reduce aldehyde or ketone to get ethanol. So here it is an example. And what is the reducing agent we get? The sodium bromohydrate or lithium aluminium hydrate. So this is the reducing agent we generally use in the organic reaction for reducing agent. So what we have propanol, that is an aldehyde, and we reduce this and we get propan 1-ol, that is a primary alcohol, you see. And then propanon, this is propanon, this is a ketone. And from ketone, when we reduce, we get a secondary alcohol, you see. That alcohol is attached to this carbon atom, and therefore it's a secondary alcohol. The reduction of carboxylic acid. If we have a carboxylic acid and we reduce by any one of these reducing agent, we get also ethanol. You see, that has ethanol. In this case, hydrogen gas or nickel as a catalyst, and we heat it and we get this. Okay. So, by hydrolysis of ester, we can get also, pointer. So, you see, so what we're talking, now we're talking about, we can hydrolyze ester and get acetic acid. You see, and with acetic acid, we have an ester, get hydrolysis. In acid hydrolysis, we get acetic acid and ethanol. And with alkali, if this is an ester with sodium hydroxide, and we get the acetate ion and then ethanol. So these are the different ways of preparing alcohols, organic alcohols. We go to, as 20 minutes is over, what we do, we take these slides, that is how do we distinguish experimentally primary alcohol, secondary alcohol, and tertiary alcohol. That we'll be taking in the next lecture. Thank you very much for your attention.